Alright, welcome back to another Containerization Crash Course. You can see it's already building this time. I'm going to show you guys what we have before we explain it. Like I mentioned in the previous videos, this one's going to be a little bit more complex of a Docker setup in that we have an application and a database working together. We're going to talk about how we can get that to work, but first, just to show the functionality, we have this student POS terminal here where I can just load 10 random customers and see information about them. I used Mockaroo for the data and MySpace era coding to make the site, and a little bit of Python. So this isn't a programming course, this is containerization. So we see the functionality. Now let's talk about how we got it to work. I'm going to go ahead and close this and go back to my terminal where I am going to Control-C to gracefully stop the excuse me, where I'm going to gracefully stop the containers, and then we'll take a look at how they're working. So you may have been able to see through all of that we've got some Flask app going on. We've got a student app and a student DB over here. And what this actually is set up is two entirely separate containers based on two different images, based on two different Docker files, pulled together by a Docker compose. So let's go ahead and ls where I'm at, and we'll see right here I've got my compose, but then I also have a directory for my app and a directory for my database. We're going to go ahead and start with the compose since it's usually a little bit easier to read through. And if I list that out, you'll see we have two separate services. A lot like when we did the Samba demo and the Tel Ubu. In this one, we have a service for our database, which is just going to build the database from that container, right? I called ./db this time so that it looks into the database directory to grab the Docker file. Then we're going to have it be called studentdb with the volumes of database data from data, and we're going to restart it unless it stopped. Now, the app on the other side builds from app, similar name, but it's got a port exposed, 5000. That's how we're allowed to see it through our browser, and it depends on the database. So if you don't include this on your compose, you are going to lose that functionality potentially, but still got the data, same restart, and then we have to call that volume right here to set it up. So we have services and volumes now. The services are going to be our images, and then the volumes is going to be the storage that holds their data. That's one way to think about it. So now let's go ahead and ls cd into app so that I can look at what's in here. I've got three files, right? app.py was the website, requirements.txt, make sure it has what it needs, and then the Docker file is what we'll actually look at in here. Because it's pretty simple this time. I'm just doing from Python slim, setting the work directory, copying my requirements.txt. So if you're not familiar, requirements.txt is a way to install, update, force, whatever you want to call it, your Python to pull the requirements needed for your app. So in this case, we're copying it in and then just running Python on this side. Very simple. Not a whole lot going on. The complex part actually comes from the database side and the application side, but let's go ahead and take a look at that really quick. I'm going to just switch over to my database and then see in here I've got the Docker file, initialize file, and the sample data from Mockaroo. Let's go ahead and cat my Docker file, and you'll see again, minimal lines. It's more about how they work together and less about the things that you set up in your specific Docker files. In this case, we're using Alpine, and I'm going to add in SQLite, or Squility? Squility. Let's call it Squility just to make somebody upset. We're going to add in Squility, and then, again, work directory this time is going to be our data, and then I'm going to copy both the initialized database and the sample data in so that once that's done, we can just shell run the Squility 3 with database.db and give it my initdb. So what this is going to do is it's going to pass my initialized file into Squility 3. I can't say that anymore. SQLite 3. SQLite 3, so that we can run that inside of the actual container. and then it's just going to tail so that it keeps going forever and it stays running. So again, the actual Docker files and Docker compose are not that complex, but to get something like this to work, you have to know what you're working with. So I'm going to cat that init really quick. And all this does is it's going to create a table based on the sample data. Again, this isn't a programming course, but to understand what's happening, you got to see this a little bit. So inside of my database, I'm going to initialize it by creating a table based on the sample data that I have going on. I ran into some issues when I was making this, so I had to use staging and then switch it over to users. There's an easier way to do that, but essentially we're using this sample data to create that table of information that we saw earlier, and then we're going to insert it from staging to users and then pull it all together and drop out these staging users. Good old Bobby drop tables there at the end. So that is the database side. Now again, I'll go ahead and go over to the app side and cat the app.py so that we can talk about that a little bit. The hardest part of this, and the reason why it's a little bit difficult to get into, isn't Docker. It's Squility 3, SQLite, right? So I need to have inside of my Python file that cursor to execute and get the information that I need. Right? Ooh, there's even a way to add a user? Maybe you guys could take a look at that if you were interested. But right here, we have a get method. And all this is saying is pull 10 random users. This is what you all saw earlier. And it's going to select from users order by random 10, limit 10, or order by random, limit 10. This part will break before Docker breaks, essentially. Your Python, your HTML, your CSS, your SQL, however you have it built, that will break before Docker. Docker's just gonna open it up. So if the things you have inside of Docker can't work together, that's when you'll run into an issue, right? So let's say I go ahead and let's go ahead and copy app.py to backup app.py, and then I'll cat the original app.py. So this is just the same thing we were looking at, because I meant to do VI, because I'm going to break it. I like breaking things, so what we're going to do in here is we are actually just going to break this. Say instead of limit 10, what if we do get all, right? Select all users, fetch it. But we're actually going to break the rows as well. And so if I escape :WQ and then go ahead and CD back up, I've got all of my stuff I need. Let's Docker compose up. And then I'm going to do build because I already had it built and I want to rebuild it so that it has the new stuff. And now we can go ahead and take a look at it. It's up and running. Let's go ahead and localhost. It looks fine. Unable to load users. Unable to load users. This isn't a Docker issue. This is an application issue. But it could look like a Docker issue. Let's see if I go to my users directly. It's null. I'm not able to actually pull that information even on the raw data aspect of it. I can see that my connection's closed, so let's go ahead and close it. Control C. Let it take the time it needs to gracefully quit. So even if you are learning containerization, just for containerization's case, to be more familiar with it and be able to work with it more, the application side cannot be ignored because Docker only runs what it's given. Right? So we can't just skip past that. In this case, I did break my app on purpose, so now let's go ahead and go back in and fix it. I did create that backup. I'm going to leave that in there because this will be posted to GitHub so that anybody that wants to recreate what happened in this video can. But let's go back. Excuse me. Let's VI back into app.py, and I'm going to re-add in my rows. And I'm going to leave the all there. Just kidding. It's all of them. Because what is a little chaos if not the best part of the day? So I'm going to right quit that, and then once again we have to go back up actually, and now I can docker compose build. Let's go back to our local host. Looks right. Ooh, and now it has all of the information, not just limiting 10, right? So this is how just a little bit of a change in a SQL can drastically break the outcome of what you were expecting. I've so many users in there. It actually breaks at 7,000 for reasons we won't get into. But it's not loading 10 random anymore. It's loading all of them. And if I go over to that users, we can now see, oh, / versus / always gets me. We actually see this in here now with all of those users. There's so much data. Oh, it's so much data. It's failing to load easily into the JSON format. There we go. We'll expand them all. It's going to take a second. And by it's going to take a second, I mean it's going to freeze my browser, so we're going to go ahead and not do that. I'm going to go back here. The page is slowing down. Yeah, we know. We know Firefox. We know. Hey, did you guys see that Firefox removed the privacy statement thing that said they weren't going to sell our data? They're definitely not going to sell our data, right? They're fine. It's fine. It's fine. It's going to be fine. So the last part I wanted to touch on this is getting changes to work is just as important, right? So I had all of that information in there in SQL. It had everything though. Looking at your tables, looking at your row or your records, you can figure out what you actually need and then work from there. You should never select all or select asterisk to get it, because it could have information that you don't want public facing, and that is more of a SQL thing than a Docker thing. But since we are using Docker to give us SQL, that is where that can come in. So once this has stopped gracefully, I'm going to go back into the app, and I am once again going to change it to just give us what we need. And an easy way to do that is to know what we're working with. So let's go ahead and cd into app. And then I am going to cat my app.py so that I can look at it. And I'll see I have these values of first name, last name, email, IP address, paired by. Let's say I just want first name, last name, email. I'm going to copy that from here. Then I'm going to VI into my app.py. I for insert mode, and then just right here, instead of select all, I'm gonna, I know how to type things, y'all. It's fine. It's totally fine. So now it says select first name, last name, email from users. So instead of pull 10 random users, now we are saying pull all users first by name and email. We could even do some sort, but I'm not going to get into that. Again, this is just to have something. I'm going to change this to say records loaded, and I am going to go up here to my button. Button, where is the button? And instead of saying load random customers, we're now going to say load customer name and email. Escape :WQ. Now we've made more changes, so let's go ahead and go back up, and then once again, Docker compose up build. Docker's gonna get mad at me at some point, but it's okay. We're almost at the 16-minute mark, so this video is coming to a close. We're just going to see our changes one more time. And as an alert, if you wanted to recover, you would just need to delete app.py and then rename backup app.py to app.py, and it would work that way. So let's go ahead and see if what we did actually did the thing we wanted it to do today, and we've got our button changed already, right? Load customer name and email. But if you'll see, we did not change everything. It can also lead to problems, but in this case, we just have these fields hanging out. Maybe we add another button that does all of it. Whatever you guys want to do with this, it is up to you. It is a student thing. Not that y'all are my students, you're just the internet, but I do teach, so that's the easiest way for me to talk about things. Anyway, this has been another Containerization Crash Course. Just make sure that once you are done with it, kill it with fire. No, I'm kidding. Clean it up gracefully. Let your Docker compose stop with a Control-C. If it doesn't stop gracefully, you can force it with another Control-C, but that's not what we're doing today. And then once you have stopped gracefully, remember to clean up. We used Docker RM to remove our actively running containers with that one there. Or sorry, that was RMI. So Docker RM. I'm getting bad at typing. I should go to a typing course. That's what I should do. Docker RM to remove our containers, and then Docker RMI to remove our images, so that then if I take a look at images, I've got Alpine, and I've got app.db.latest, but I don't have anything else. So this is all going good now for me. It's nice and clean. Is Docker ls? No. Docker show? It's the end of the video. We're doing great. So now we don't have anything running and using up our system. Like I mentioned, I am going to go ahead and throw this into GitHub and link it in the description so that anybody who wants to follow along can. But this has been another Containerization Crash Course, a really long video because we had to get into a little bit of programmatic knowledge to back up our growing containerization knowledge. Either way, bye.